Hello, welcome to this video. This is segment of a circle. In this video, we are dealing with segment of a circle. And I will start by the meaning and description of a segment. A segment is a part or portion of a circle bounded by a chord and an arc. So segment is bounded by two parts, a chord and an arc. Now, segment can be found as part of a circle, and also we have segment as part of sector. So first of all, let's start by talking about segment as part of a circle. Now, here we have a circle, and if we have a chord that divide this circle like this, if you have a chord like this, the shape that we are having here actually is known as the segment. So here now we have this is the minor segment, and then this is the major segment. So segment, that's why we say segment. If we extract this out, we are going to have something like this. So this is how segment is. This is a chord, and then this is the arc. So that is how a segment is formed from a circle. And also segment can also be found as part of a sector. Um, for instance, here we have a circle. If this is the center of the circle now, and then let us try to construct a sector out of it. Sector has two radii, so this is one radius, and this is the sector called radius, and then we already have our sector. And then if there is a line connecting the point at which the radii touches the circumference of the circle, that if you construct like now, this is actually a chord, this is a radius, this radius, this is a chord, and then from here to here, this is the arc of the circle. Now if you extract, and this is the angle that is subtended by the sector, and if you extract this sector out, we'll be having something like this. And then that means we also have a chord. So the part we are having here now, this is actually a segment which is part of a sector. So this is the angle, and then this is radius, and this is our radius. So here we are having a sector. Now by the time we divide this sector, we can also divide this sector. That is going to give us something like this. And then if we separate, so at this point now you can see that we are having the sector is what we are having here. And then so a sector can be divided into a triangle and a segment. So from this sector, we are now having a triangle here, and we're having a segment, and then this is a triangle and a segment. So a sector comprises of a triangle and a segment, and that is where we can derive formula for finding the segment of a sector or segment of a circle. Now let's talk about formula of area of segment. How do you find area of a segment? Area of a segment, as you see now, anytime if you can subtract or remove a triangle, if you have a sector given to you, this is a sector now. So that's why we say that area of a segment is equal to, first of all, area of a sector, because segment is part of a sector. So first of all, you have your area of a segment. If you have this whole sector, then by the time you can remove the triangle, if you detach this triangle out of this sector, what you will be left with is a segment. So to find the area of a segment, what you do is to subtract the area of a triangle from the area of a sector. That means detach this triangle from this sector, and what you'll be left with is your segment. So now we are going to have area of a segment is equals to area of a sector minus area of triangle, as we have just explained here. So, and that's going to give us area of a sector is going to be what, theta over 360 multiplied by pi r square, and then going to be minus area of a triangle is basically half times base times height, or half base times height. But in this case now, the area of this triangle is not going to be like that. We are going to have theta over 360 times pi r square minus, we are going to have pi, 1 over 2 pi square sine theta. So this is the formula we are going to use. This is the another way of finding the area of a of a triangle is half times r squared sine theta. Now we're going to use this formula to actually solve one problem on segment of a sector. And then here is the problem we are dealing with. And it says calculating the area of a segment. How to calculate area of a segment of a circle? Here we have this shape here. This is our radius, and then the shaded part here is what is called the segment. Now they say calculate the area of the shaded portion, shaded segment in Fig 12.51. Leave your answer in terms of pi. So we are going to have, this is actually a y equation. So we're going to solve that right now. From this, our radius is given to us as 3 cm, and our theta, which is the angle associated by the sector, is 120 degree. And then the area of this segment now is going to be the area of this entire sector, subtracting, then we'll now subtract the triangle from inside. That's going to give us area of sector minus area of the triangle. When you can do this, you can get your area of your segment. So how do you find area of a sector? Area of a sector, like we just derived, is equal to theta over 360 times pi r square minus area of a triangle, which is half r square sine theta. Let's do that now. Our theta is 120 degree over 360 degree times pi, which is, okay, they actually ask us to leave our answer in terms of pi. I will remain pi times, which is 3 cm, that is 3 cm square, which is 9 cm. 3 cm square as radius square, and that is 3 square is 9. So we have 9 centimeter square minus area of triangle is half times our radius square also, which is 3 square, which is 9 cm square sine theta. Our theta is 120, that is sine 120 degree. Then we are going to have let us simplify this. 0 take 0, and then 12 into 12 is 1, 12 into 36 is 3, and then 3 can go into this 9. 3 into 3 is 1, 9 is 3. Here we are going to leave this like that for now. So we are going to have what we are now left with in this place is 3 times pi. That is going to be 3 pi cm square minus, say we have our half times 9 cm square times our sine 120 is 0.8660. So we are going to have 3 pi cm square minus, if you do 9 times this is going to give us 7.7942 cm square all over this 2, and then we are going to have 3 pi cm square minus, if you divide this by this, is going to give us 3.897 cm square. And this is also the same thing as 9 root 3 over 4. So this and this are the same. So you can choose to express your answer in this form or this form. So if you want to put your answer in this form, we are going to have 3 pi cm square minus, if you choose this form, we are going to have something like this, 3.897 cm square, and then that's, you can actually leave your answer in this form if you are going to use this. But if you are going to use this one, you are going to, it's going to become 3 pi, that is, or 3 pi cm square minus 9 root 3 over 4, and then you do that, we can factorize 3. That's going to give us 3 into pi minus 3 over 4 root 3, and then we put our cm square outside. So you see that the answer is left in this place or in this form. So whichever form you want to you choose, you'll see arrive at the same answer. Thanks for watching this video, and subscribe to this channel for further video. And as you do so, you will not remain the same. Thank you.